Spinal thalamic tracts. Remember, I'm not going to mention the lemnisci to you. Spinal thalamic tracts coming in. Trigeminal thalamic tract, gustatory inputs coming in. Optic, inferior colliculus, which in this case is going to be auditory. The superior colliculus coming in. Globus pallidus, once again, which is basal ganglia. Brainstem, reticular formation. As the semester goes on, we're going to get to the reticular formation, and you're going to realize the reticular formation is obnoxiously critical in so much of what you do. Sensory pathways. The amygdala, olfactory cortex, basal ganglia. This is overwhelmingly limbic. So from there, we started looking at the individual slides of signals coming in. Signals coming in, signals going out. Look at these signals going out. Visual cortex, auditory cortex. Parietal occipital cortex, cortical regions, cortex. Prefrontal cortex, cingulate gyrus, cortex. Frontal cortex, motor, premotor cortex, somatosensory cortex. So many of these signals are headed out to the cortical areas. This is a major kind of pathway for all signals that come through your brain getting to all of these higher cortical areas for processing. VPL, VPM, both going to the somatosensory cortex. So all of those signals we were talking about earlier, coming through here, come through these two to go to somatosensory cortex. So let's start mucking you up. Let's do damage. You ready? I'm going to go this one first. It really is critical for you to work on understanding this figure, knowing these pathways. What you're going to see and what would really make really nice sense if we could do it would be to bring this and overlay it with the motor pathways, just to show you how damage at different levels can have different effects. But you understand why damage along here really is different from damage right here. Let's say you have trauma in the lumbar enlargement area, the lower lumbar enlargement area. Okay. These signals come in and they bypass the lumbar enlargement. Why do you think they bypass the lumbar enlargement? They don't synapse. The lumbar enlargement has a lot of synapses in it. Okay? They bypass it. So if I had damage here, I would damage both pathways, anterolateral pathway systems going up. Whereas if I had the damage just above the lumbar enlargement, I would lose all somatosensation. So you really have to pay attention to those synapses. Those synapses and where they're crossing over really makes a difference. And the higher we get up here, the more difficult it is to isolate damage. Usually, once you are up and above the cervical enlargement, you're going to have damage that can involve almost anything and everything typically, until you get back to the thalamus. So, all right. So here we go. Somatosensory loss on one side of the body, unilateral. Cortex or thalamus? That's it. Has to be. And you can prove it to yourself. You can say, all right, I want to knock it out here. All right, you knock it out there. This comes down, I lose that. This comes down, I lose that. This comes down, goes there. I lose that. This comes down. That, I'll lose there. Where am I doing my damage? Here? In the pond?
Yeah.
In the ponds?
Yeah.
Here? Okay, I'm probably going to lose this one too. All right? Because once again, in the ponds here, you're probably not going to have this damage or this damage. You're going to have this damage. So I'd lose the face too. So when you look at the damage, just trace each line down. It will make sense. I will try to have this blown up as big as possible for you on an exam, so that you can have extra, pages of figures to work with. Cool. Brain problems that are manifesting themselves as loss of sensation. And the minute I tell you about discrete, here's knocking out the pons. It's knocking out all of this. The way it shows it to you here is very nice and little discrete thing. It's really knocking out pretty much the left side of the pons, because it's knocking out both of these tracks that cross and come on down. So. Now we're losing everything on one side below the face. So just a little discrete, and this damage now, once again, this could be just referring to both the loss of the posterior column, but it could easily include all of this. So once again, it's a little sloppy the way he's drawn it out.
So if you don't mind me asking, they still have temperature and touch, correct? Because when I look at it, I don't see it over the blue.
There's no way to tell what it is from what he's shown you there.
Okay.
Okay? When I ask you a question, I will be very specific as to saying what has been lost. Does that make sense?
Yes.
Okay. Peripheral problems. Peripheral problems happen. Polyneuropathies. Polyneuropathies are weird. Symmetrical polyneuropathies are not weird. Symmetrical polyneuropathies are. In that, on occasion, you'll have somebody that loses sensation in the same part of their body on both sides. And I have no good explanation for you. So, it happens. I don't know why. But, more likely to happen with diabetic neuropathy, though. Isolated nerve damage. You've damaged the nerve. You have a loss of sensation for whatever reason. So the various cord syndromes. Transverse cord lesion. You cut the cord in half, all right? You cut the cord, you lose signaling. End of discussion. You lose it all. You lose afferents, you lose efferents. Hemicord lesion, one side, and it does affect both sides because you have to remember this signal here is coming in, over, and down, right? And then it heads up. So if it's coming in here and we've lost that, it's gone. That's why you have to know where things cross. Crazy things like this.
So if it happened on this side, then this side
It-
will last.
okay. Slow down. So, if you knock out this side, this would be green, this would be striped.
Uh-huh.
And you'd have the little green piece up there. Yep.
And then the sensation coming this side, this one, for this one.
I'm missing something.
Where is the dorsal root ganglion? Will be this side or this side? For this,
You're the one, you wanted the damage on this side versus that side.
this side, damage this side.
This side, you got that?
Okay, so the sensation, the dorsal root ganglion will be this side, coming in this way, sensation coming this right side.
You have now lost this dorsal root ganglion.
Oh, okay.
Because when you cut the cord here, you lose the inputs coming in here. Does that,
Yeah. yeah,
Okay.
yeah.
central cord syndrome, small lesion, little tiny guy. What you're really losing here are the signals that are crossing here, the signals crossing to there. So you're losing the signals that are coming in and crossing to the two interlateral pathways. The larger one, we've lost everything. Once again, you'd have to follow the neurons coming to the bladder and groin to see what's going on, to see how that's spared. Posterior cord, okay? You look at that posterior cord there, you go, whoa, wait a minute. That's the posterior spinal artery. That's it. Huh, hold on. Look at this. This is the anterior spinal artery. Oh, darn. Those now should make better sense to you in thinking about that cross-section of the cord showing the spinal arterial flow. So in one, we've lost vibration and proprioception. In the other one, we lose pain, temperature, motor. So. And then we wrap things up looking at peeing. I don't think we went anywhere much beyond peeing. Oh, wait a minute, I did find some more slides. Right. Ta-da, that slide. So please remember that slide. These show it to you very nicely. Okay? So just remember to look at those. That's what's on your exam. Same format as first exam. You know, there'll be a few spots for you to write answers, a few things for you to label, a couple multiple choice questions. What else? What can you think of?
When you're talking about plexuses, you mean the plexuses in the chapter?
Plexus, cardiopulmonary plexus.